So, good afternoon, everyone. Welcome to week two of the live session for design of steel structures. I'm your TA Danish Bashir. So, in the last live session, we have seen the general considerations for the design of steel structures. Then we saw advantages and disadvantages. We also see the different types of codes that we have to use for the design of steel structures. After that, all those things, we went to see the uh, different types of loads, what are the loads that are going to act on our system. So among all those loads, the loads, wind loads were one of the important loads. So we consider the calculation of those loads only. So in today's class, we will be seeing the simple connections in our steel design. So what are the simple connections like in steel structures? Like for example, we have two members, like we have member one. So we have member one and we have another member second. Okay, we have member second. So these are to be connected with each other. They have to be connected with each other. So for that connection, okay, for that connection we need different types of connections, so as different types of members will be connected to each other. So these connections are connected by using things which are known as fasteners or connectors. Fasteners or connectors. Connectors, we use fasteners or connectors for connecting two different members. So members can be of any type. Member can be a tension member, it can be tension member, it can be compression member, tension member, compression member, or it can be flexure member. Okay, like tension member, I can see it's a steel rod. It is being pulled by P, or it can be compression member like a column like this. It is being acted by upon force P, or flexure member like this. Okay, transverse load P. Okay, so this is A, I can call this as A. This is B, I can call this as B, and this is C, I can call this as C. Okay, these are the different types of members we have to see. So these different types of fasteners are like, what are the different types of fasteners? So fasteners that are available there are, let me add a page. So different types of fasteners that are available there are, first one is rivets. Okay, second type of important fastener is bolts. Okay, and third type of important fastener is, we use welds. Okay, we either use, and the process of using rivets is known as riveting. Okay, and similarly the process of using bolts as fasteners and you connecting different members is known as bolting. Okay, bolting, and same, this is known as welding. Very simple. Okay, so these different types of things are used: rivets, bolts. These different types of things are used. Actually, one second, sorry. So this is known as riveting, bolting, and welding. So these different types of fasteners like rivets, bolts, and welds are used depending upon the requirement of the different members being joined. Okay, it depends upon the members. Okay, or we can have pins also. Pins are sometimes used. Okay, pins are also used. Okay, the forces exerted by one element on another are transferred through these transfer fasteners. We should therefore be adequate to transfer the forces safely. So like what is that? Forces transferred between the members is transferred via fasteners only. Okay, via fasteners. Okay, so uh, these should be adequate enough so as to transfer the forces safely. Fastener should be adequate enough to transfer forces safely. Okay, this is important. Okay, so uh, I already told you what are the different types of fasteners used. These are the rivets, these are the bolts, welds, and pins. Okay, so today we will be seeing the riveted connections. Okay, so first important thing is riveted connections. Okay, so what is a rivet? So if we will look at the conventional definition of a rivet, so a rivet is made up of a round ductile steel bar piece, mild or high strength steel called shank. So here in the figure, this is made up of high or mild steel like this part. This is known as shank. Okay, we called it as a shank. Where with one head, it's also having one head. This is known as head. Okay, head. So what we do is that we insert like for example we have one member here like this. Okay, this is one member to which another member is attached like this. Okay, this is continuous from this side, this is continuous from this side. So we put a fastener like this from this side also, and then there is head from this side also, and there is head from this side also. Okay, there is head from the sorry there is head from this side also. Okay, there are heads from two sides. So this type of connection is known as riveted connection. Okay, uh, this head is of different shapes. Okay, the different types of shapes of head that are being used for riveted connections is like this. One is snap head, another is pan head, another is flat countersunk head, and another is round countersunk head. Okay, so what I showed is earlier is like this. What I showed here is shown here also. Like we have one type of we have one plate here. This is one plate. Okay, this is another plate. We are inserting fastener in this direction. Okay, this is the fastener. Okay, this is the fastener. So this is manufactured head from this side. When this will go from this side, then it is hammered from this side, and one head also becomes from this side. Okay, this is a type of process that is using used in riveting. Okay, um, So, usual form of the rivet head employed in structural construction is the snap head. This type of head is mostly employed. Okay, so this is one of the common type of rivet head. This is mostly employed rivet head. Okay, so keep that this in mind. This is one of the most employed rivet head. Okay, so. mm, So they have actually projections beyond the plate like this, projections, snap heads and pan heads. Okay, they have projections beyond the plate where they are used. Okay, so the shank is made of length to extend through the parts to be connected and with sufficient extra length for second head to be made at the other end. So this shank should be I mean to say that long enough that it should cover this amount of thickness, and then it should be more long enough from this side so that it can be hammered from this side to make a head from another side, because one head is already from this side, so it is to be hammered from this side to make one more head from this side. Okay, this is the thing. Okay, so you be in here connected. I will come in few minutes. Okay. So this is the initial clearance I already showed you. This is the initial clearance. This is the manufactured head. This is the length and this is the grip. Okay. Whatever goes in between the plates, that is known as the grip of the this grip of our riveted connection. Okay. Uh, So, when this grip of the rivet becomes long, the rivet is subjected to bending in addition to bending and shearing stresses. Okay, usually there is bearing stress like this, and there is shearing stress like this. Okay, when the length is more, it is subjected to bending stresses like this also. Okay, it has so this grip has an important role to play. Okay, there is one thumb rule is that important the grip length should not be more than 4 times the diameter. Okay, length should not be more than 4 times diameter. Okay, diameter of the rivet. And I already told you the head on the other hand can be formed by hand hammering when the rivet is red hot, or hydraulic pressure driving by pneumatic pressure driving. Okay, so how the heads are formed on the other side? It can be done using hammering. Okay, I can write rivet heading. So how this is to be done? Rivet heading. So first case is this is done by hammering, and in second case it can be done by hydraulic pressure driving. Okay, hydraulic pressure driving. Okay, hydraulic pressure driving by pneumatic pressure driving, or by pneumatic pressure driving. Pressure driving. Okay, pneumatic pressure driving. Then moving forward, and the diameter of the shank, this 5. So it is known as nominal diameter. Okay. Okay, this is known as nominal diameter. So there is actually for this a hole slightly greater than the nominal diameter is drilled in the parts to be connected. So this hole and this hole, this is slightly greater than the diameter of the shank, which is to be inserted into it. Uh, the rivet is inserted and head is formed on the other side. I already told you. This complete process is known as riveting. Okay, the rivet may be placed in a cold state or may be heated to red hot state. That is important. Okay, when the rivets are heated before driving, they are called hot driven field rivets. Okay, heating, heating before driving. These are known as hot driven field rivets. Okay, okay, hot driven field rivets, or hot driven shop rivets. We can also call them hot driven shop rivets. Hot driven shop rivets. Okay, okay, shop rivets. Depending upon if they are placed in the field or in workshop. If they are placed in workshop, then they are called hot driven shop rivets. If they are placed in using heat riveting in field, they are known as hot driven field rivets. Okay, so when this rivet is hot and is driven into the hole, the diameter of this rivet is exactly equal to the diameter of the hole, and that is known as the gross diameter of rivet. Okay, gross diameter gross diameter is equal to the hot diameter of hot diameter of sorry diameter of hot rivet. Okay, diameter of hot rivet. Okay, so the hot rivet becomes plastic, expands and fills the rivet hole completely in process of forming a head at the other end. This is okay. On cooling, the rivet shrinks both in length and diameter. Due to the shortening of the rivet, residual tension on an unprecedented amount in the shank and some compression in the plates to be connected. The compression causes the friction to slide between the plates and is called a clamping action. This is known as clamping action. You know, when this hot rivet cools down, it inserts the force from both the heads and it causes the friction within the plates. This is known as clamping action. Okay. Due to the reduction in the diameter of the shank on the cooling, the space means between the sides of this space means remains between the sides of the rivet and the hole. Okay. The use of cold driven rivets is limited. This is limited because it may not be feasible under the equipment for making the heads in the field. Okay, the riveting process is not completed with a proper inspection, so there has to be proper inspection before this. The rivet placed should be tight and properly. Second head connection with the shaft should be made at the other end. Okay, a defective rivet can be detected by tapping with a light hammer. If the rivet is loose, it will give a metallic or ringing sound. Such loose rivets should be detected and replaced. So using a hammer we have to hit it from one side. Using a hammer we have to hit it from one side. If it is loose, it will make very small this metallic sound. So that metallic sound we have to detect, those rivets we have to detect, and we have to replace those rivets. Okay, because it's very important in our steel design, because these connections are very important as they keep our structure together. Okay, so moving forward, those symbols that are used in riveting is, these are the basic symbols. Okay, the symbols you used. Okay, the knowledge of rivet symbols is essential for a field engineer to read the drawings. So, however, it is in solid example the symbol have not been observed strictly. Okay, description: shop rivets and field rivets. Okay, round head both sides. If the both sides are round head, on the both sides, shop rivet is shown by this, field rivet is shown by filler dot. Okay, countersunk near the side. Okay, it is shown by this symbol, and if it is field rivet, it is shown by this symbol. Countersunk for far side is shown by this side and this sign. Okay, countersunk both side, it is shown by this sign in shop rivets and this sign in field rivets. Okay, so what has to be the material, rivet material is, the rivet should conform to IS 1929 and 1928 and IS 2115 2155 of 1982 as appropriate. High tensile steel rivets should be manufactured from steel conforming to IS 1149 1982. So this is clear to you. Now coming to the types of riveted joints. So there are two main types of the riveted joints. Like we can see that here this is one plate. There is his one another plate. They are joined like this end to end, and riveting is done in this direction. This is known as a lap joint. Okay, we call this as a lap joint. Okay, another type of most famous joint is butt joint. One plate is from this side, another plate is from this side. We plate put one cover plate over it and then join it by rivets on the both sides. It is known as butt joint. Okay, so we will see the lap joint first. So this is lap joint first. Okay, lap joint. Okay, so in what happens in lap joint is the two members to be connected are overlapped and connected together. So like here you can see that two members, member one, this member one and member two are overlapped. They are overlapped here. I have overlapped them together and are connected together by rivets like this and rivets like this. This type of joint is called as lap joint. A single riveted lap joint and a double riveted lap joint are shown here. Like this is single riveted lap joint. Like all the rivets are in single line. That is why it is known as single riveted lap joint. And if this is a double riveted lap joint, like two plates are put like this, and then there is a double lining of rivets like this. This is known as double riveted lap joints. So if we see that this load P is acting along this direction, this is acting along this direction. So there is some eccentricity between the 2 points like this E. So because of this, there is a bending moment created at this lap joint. Okay. So undesirable bending at the connections. Okay, so in order to minimize this effect, the bending two rivets should be prevented. Lap joint is at least two rivets in the line should be prevented placed. Okay, also due to the eccentricity, stresses are distributed unevenly across the contact area between the rivets and members to be connected. This puts limitations on the use of lap joints. So because of this limitation, like eccentricity is there, eccentricity is there. Because of this, lap joints are not used that much. Okay, we have then butt joints. Okay, let me write eccentricity is there, which causes undesirable bending. Okay, which causes undesirable bending like here. Okay, sorry, I made it in the wrong fashion. So this will be like this. Okay, couple will be like this. So in butt joint, so in two butt joint, two members are placed end to end. Like you can see that one member is placed like this, another member is placed like this. Okay, these are placed end to end and not like overlapped with each other, stacked head to head. And another additional plate or plates are provided on either one side or on the both sides, like this side and this side. And then the rivets are placed. If the cover plate is placed on only one side, like this, we called it as single cover butt joint. Okay, this is important, single cover butt joint. Okay, if it is placed on both the sides like this and this, it is known as double cover butt joint. So the forces will be transferred like this in this. Okay, single cover butt joint. Okay, and here I can show you is single riveted single cover butt joint. So there is only one cover plate and there are only single lines of rivets on both the sides. So this is known as single riveted single cover butt joint. So if there is double line of the riveting like this is known as double riveted and there is only one single cover, so it's known as double riveted single cover butt joint. Okay, now double cover butt joint is two plates are on the both sides. So like there can be also different types like double cover butt joint and other things. Okay, so why we prefer butt joints is because of these two reasons. In case of double cover butt joints, total shear force to be transmitted by the members is split into two equal parts, and the forces act on each half as shown in the figure. So here I can show you the butt joint like this. Force is split into two parts like this, p by 2 p by 2. So on each side of the rivet there is a shear force of p by 2 only and p by 2 only. But in case of lap joint, if you see that there is a shear force of p and p on each side, like this is p and this is p. That is why butt joints are preferred over uh, lap joints, because shear force acting on a single rivet is half of the shear force that acts on this lap joint. So this is written in this statement. Okay. And one more thing, in case of double cover butt joint, eccentric force does not exist and hence bending is eliminated. If you see here, there is no eccentricity in the force. Both forces are in the same line, so there is no eccentricity. E equals 0, so there is no bending. M equals 0. So that's why we prefer this type of joining. Okay. So now the failure in the riveted joint. So there is always failure everywhere. So the different types of failures are, one will be the shear failure of the rivet, like it will be the shear failure of the rivet, that is known as shear failure of rivet. Or there will be the shear failure of the plate, like this. This is known as the shear failure of the plate. There will be the, or the plate will be fully teared like this. That is known as the tearing failure of the plate. Okay. Or there will be splitting of the plate, like it will be split into two halves. That is known as splitting of the plate. Or there will be the bending failure of the plate. It will bend like this. That is known as the bending failure of the plate. Or there will be the bearing failure of the plate, rivet. That is known as bearing failure of the rivet. So I think that is enough for today. Thank you everyone for joining this session. Thank you.